Mars, known as the Red Planet and the one planet which has always been a hot topic for scientists to research and explore, is currently a frigid planet. Also known as the Red Desert with riverbanks and deltas that have completely dried up. It's clear that scientists are constantly trying to answer the question that where did all the liquid water go? Why can't it be seen on the surface anymore? Well, it's evident with the topography of Mars that it indeed had riverbanks and shorelines. The presence of water made Earth a biological paradise while Mars became an arid wasteland. We dwelled on the same, and here is our theory for the same. We are aware that on Earth, both the surface temperature and pressure are high enough for water to exist in all three states that are solid, liquid and vapor phases. This is different on Mars. The low pressure and low temperatures do not permit water to be stable in the liquid state. Therefore, water on Mars is usually only stable both as ice on the surface and as vapor in the atmosphere. There is a lot of evidence that liquid water once existed on Mars, both in the forms of rivers and lakes or oceans. There have been instances where scientists have found flow pattern, created by small rivers that turn into bigger rivers, a so-called dendritic network on the surface of Mars. Most of these features were created a long time ago, almost over 3 billion years ago. This was a time when Mars was known to have a different climate with a thicker atmosphere providing the necessary pressure and temperature conditions for liquid water to permanently exist at the surface. It was also concluded that when it boiled down to the water at Mars, some of it disappeared into space. Water molecules, pummeled by particles of the solar wind, broke apart into hydrogen and oxygen atoms, and those, especially the lighter hydrogen atoms, sped out of the atmosphere, lost to outer space. New studies are constantly made and theories are being deduced. A recent study concluded that most of the water went down, got sucked deep into the red planet's rocks. It remains there, trapped tightly within minerals and salts. It is being said that 99% of the water that once used to flow on the surface of Mars still has a high possibility of being there. All of the water thought to be trapped in the Martian crust today simply means that the planet had far more surface water in its youth than previous researches and studies had estimated, and that early epoch may have been even more amiable to microbial life than previously perceived by any scientist or depicted in any study. The scientists estimated that the depth of the rocks or the surface through which the water has seeped in would have been 100 to 1,500 meters, or 330 to 5,000 feet. The most likely depth was about 2,000 feet, they said, or roughly 1/4 as much water as is in the Atlantic Ocean. Prior research evidently suggested that most of Mars's water escaped into space as its atmosphere was stripped away by the sun's radiation. The fate of the planet's ancient water was previously estimated supported the kinds of hydrogen found in Mars's present atmosphere. As water vapor in the air is bombarded by ultraviolet radiation from the sun, hydrogen gets stripped away from the oxygen in water molecules. Being a lightweight gas, that free hydrogen easily escapes into space. Some of the water vapor, however, contains a heavier version of hydrogen called deuterium, which is more likely to stay within the atmosphere. Today, scientists presume that there is still water equivalent to a global ocean 65 to 130 feet deep, but that is mostly frozen in the polar ice caps. A multitude of dried-up riverbeds, deltas, lake basins, and inland seas make it clear that Mars once had tons of water on its surface. It may have even had one or several different oceans in its northern hemisphere, although that's a matter of intense debate. Today, apart from a possible series of briny underground lakes and aquifers, most of Mars's water is locked up within the polar caps or in ice buried below the surface. Without a machine, presumably, there are no thanks to observing directly what proportion water was on a younger Mars quite 3 billion years ago. But the hydrogen atoms floating today within the atmosphere of Mars preserve a ghostly hint of the traditional ocean. Mars might have started with a similar ratio of deuterium to hydrogen as Earth, but the fraction of deuterium increased over time as the water evaporated and hydrogen was lost to space because the heavier deuterium is a smaller amount likely to flee the atmosphere. Deuterium may be a slightly heavier version of hydrogen, it's an additional neutron in its nucleus, and is a smaller amount likely to flee into space. On Earth, water is additionally absorbed in rocks, but it doesn't stay there indefinitely. The movement of Earth's crust pushes rocks down into the mantle, where they melt, and then the molten rock and water come back up through volcanoes. On Mars, volcanism, like liquid water, appears to possess gone away way back. By contrast, Mars's stagnant crust may have doomed the Earth to become a bitterly cold desert. Not all water-trapping minerals are created equal, either. Some clays can hold around 13% water, while others can have quite 30%. What's beneath Mars's surface remains largely a mystery for now. Hoping for mankind to someday be able to unravel this mystery. Thank you for watching, follow us for more.